This video is to go along with the notes for Unit 6, Lesson 2, Expected Value. So we had a warm-up, and I asked how many ways can you roll doubles on 2 dice, and how many ways can you roll a sum of 8 or more on 2 dice. For this, we need to know the sample space for rolling 2 dice, which sometimes can be a little bit tricky. But what we have to do is understand that the 2 dice are separate things. So I have dice 1 and I have dice 2. Each of them have 6 outcomes that we're going to treat as equally likely. So to answer that first question, how many ways are there to roll doubles on 2 dice? What I have to look at is I have to look at rolling a 1 on dice 1 and 1 on dice 2, a 2 on dice 1 and a 2 on dice 2. And so what happens is I end up with this diagonal right here. And so as I can see, there are 1, 2, 3, 4, 5, 6 outcomes in this diagonal. So the answer to that first question would be 6. So there are 6 ways to roll doubles on 2 dice. Now, for the second question, how many ways can you roll a sum of 8 or more? So we're looking for a sum of 8 or better. So here I'd be looking at, let's pick a different color. Let's go with purple. I'd be looking at all of these values would work. 9s would work. 10s would work. 11s would work. And even the value of 12 would work. So I just need to count how many squares or how many outcomes that is. For the 8s, that would be 5, 4 more for the 9s for a total of 9, 3 more for the 10s, which would give me a total of 12. And then I'd have 13, 14, 15. So there are 15 ways. There are 15 ways to roll a sum of 8 or more on 2 dice. And so that's the warm-up. So again, the key to this is understanding what our sample space is. We need to know that sample space to be able to answer this question. Now in this, we did a couple of activities in class. One was about rubber duckies. And then we decided on some vocabulary. And so in rubber duckies, we looked at a game where students were at a carnival, going to pick rubber duckies out of a pool, and there were different symbols on them. And you had to pay so much to play this game, and depending on the symbol that was on the bottom of the duck, you would win a certain amount of money. And they were asked to calculate something called expected value. Well, all expected value is it is a long-term average, the long-term average of a probability distribution. And when I say long-term, what we're talking about is this is what would be your win or loss, in this case for money, if you were to play the game a lot of times, like hundreds and hundreds of times. This would be what you would win on average or lose on average, depending on the type of game. And there is a formula for expected value. And the way the formula for expected value is we represent it with E and then our random variable X. And what we're going to say is that we're going to look at X sub 1 times that probability of X sub 1. And then I'm going to say I'm going to add to that X sub 2 times the probability of X sub 2. And I'm going to keep doing this until I run out of probabilities. So I'm going to say, x's and their probabilities. So I'm going to say x sub n, for instance, times the probability of x sub n. So I just keep taking each x value times its respective probability, and I do all of them until it's completely exhausted, and then I add all those together, and that gives me my long-term average of that probability distribution. That means if I were to play that game hundreds and hundreds of times, this is what I would stand to win or lose on average per game. Now, a fair game is a game whose expected value is 0. Okay, so a fair game is a game where its expected value is 0, meaning in the long run, your average for winning or losing or whatever it is you happen to do is 0. You're not winning anything on average, and you're not losing anything on average. And a lot of times we're going to be asked to find the value that makes the game fair. Like, how much should I pay to play the game to make it fair? So if I have a positive expected value, the game is in my favor because it means in the long run I'm winning money. If the expected value, though, is negative, the game is in the person who's running the game's favor. So, like in the rubber ducky example, the whoever was running that carnival game, it's in their favor because it ended up with a negative expected value. And if I wanted to make it a fair game, I would have to calculate the price so that I would pay it and the expected value came out to be 0.